just a quick video to announce that next Saturday, this is the second of November, at about uh, 10 a.m. CT, I will be streaming to build one of these. This is, as you can see, an Apache collective, a DIY Apache collective that you can build yourself very easily and for just a fraction, a really small fraction of what's out there commercially for from other bands. It's fully functional. All inputs are functional. It's really easy to build. It's very inexpensive, and it is a very nice tool to have if you don't want to spend 400, 500, even $600 for one out of the shelf. This you can build it for less than 100 bucks, and it features, as I said, all functional inputs. It's a great travel. I think it's about 45 degrees, more than enough. It does feature friction ring and also a front USB Type B connection, so you don't have to have a wire coming out of it every time. You can just mount it on, and when you're gonna play, and just take it out once you've done flying. In my case, I preferred having it like this because I use it in an office chair, and then when I'm not flying, I just pull it out. So yeah, this is gonna be a series of videos I'm gonna be doing, and after that I will be uploading the stream to YouTube. So for everyone who cannot join live, they can review it afterwards. And the reason it's a series of videos is that because it is a very simple build, it does take a little bit of time, and we will be doing uh, different sections of the build every time. So it might take, I'm thinking probably at least two, but could be up to 3 or 4 videos to complete the build. I don't want to, stay 3 hours like doing small things that are not interesting in a stream. So yeah, that's why I'm probably going to try to do shorter streams, but more of them, so you don't get bored with long times of soldering and wiring and crimping and things like that. Okay, I hope to see you all there, and if you have any questions, please do not hesitate to contact me. Okay, let's put some music, low volume. And let's get started. Okay. Let me know if the music is too loud. But let's get started. So, okay. Hello, welcome everyone. Thank you for joining. And let me start by explaining what are we going to do in this one. This is the first one of a series of videos in which I'm going to show you how to build first an Apache collective like the one you can see here that you can use for actually any helicopter. I mean, it does have the grips of the Apache, but you can fly any helicopter with it in DCS. And in a near future, I'm thinking probably extending the series to other items that I have already built, like button boxes, maybe a track AR, battery powered track AR, and maybe at some point, if this series is successful and people is interested, we could even get to a point that we build this in the stream. So as you probably already know, if you're here, this is an Apache TDAC. It's fully functional, and yeah, it's awesome. But let's start. Let's start with the collective, which is what we came here to do today. I don't have an agenda, so it's going to be a little bit of an improvising. I do know that I'm not going to be able to build everything in one video, so it's going to be a series. Especially because although it's a very simple build, um, there are some parts of the build that are really boring and can be a little bit long. So, for instance, I've already printed the grips, and what I have already done, these are split in half. I've already glued together and sanded, and that's something that you really don't need to see. It's just, super gluing it together, filling it up a little bit, sanding, painting. That's of no interest in the stream. So yeah, whenever we reach a point where something that it's not really teaching you anything, we will stop there and leave it for the next episode, which I'll be doing with that part already done, so you don't have to, stay and watch a very long and boring process of it. Let me talk to you a little bit about this collective. As I mentioned, it does feature all the buttons and switches in the real, as far as I know, in the real thing. All the buttons are working, even though some of them are not modeled in. Let me just lower the volume of the music. It's distracting me a little bit. Yeah. Okay. So, yeah, as I was saying, even though there are some buttons, like the triggers, for instance, that are not modeled in DCS because, and will never be because they are of no use in a simulator. These are, I believe it's called a BUCS, BUCS, which is a backup control system that basically disables the how you call them, the electronic control system and gives the pilot physical, like mechanical control of the cyclic and collective. That's obviously not going to be ever modeled in DCS because we don't have mechanical input. But I've done them so you can still use them. So for instance, I use this uh, to act as a modifier, and therefore I can use any other button for anything other than its proper use. So there's another button, for instance, this one here is the polarity and board side switch. So right is polarity, sorry, Yeah, polarity, and left is board side. Board side is deprecated in the real thing, so it does nothing, but you can still use this button to do something else, like, I don't know, SRS radios or whatever you want to use it for. And as I said, if you, in my case, and you can do whatever, you can set it up the way you want, but in my case, when I press the trigger, I can use any of these inputs in both triggers to the same. So for instance, I use this one as the flight grip, sorry, the mission grip trigger to as a modifier to use all these, and these ones, like for instance, turn on the engine. So I can put the power throttle in idle and increase the throttle and all that with this grip only. Everything is working as I said. All these four-way switches work. There is a joystick here for the cursor. Yeah, so basically that's it. And then in the box, which I'm very proud of because it's very compact, a small one. I like it because it doesn't take too much. It features a friction ring, so you can tighten this nut here, this bolt rather, and it will hold the collective. Though I ended up adding a counterweight because I didn't like flying with the collective too tight. So whenever I was adding or decreasing throttle, the the lever would stay at its place as you would expect, but it was a little bit too tight for my liking. So I ended up using a counterweight, and now it's quite soft, the friction ring, but it does hold its position, so that's awesome. That's what I was looking for. Also, it does feature a front USB Type B female connector, so that way I can just unplug it and remove it from the chair because I don't have it permanently mounted in my chair. I'm just using squares like the ones you use for a shelf in my chair, and then I have a couple of bolts here with I think these are called butterfly nuts maybe, that I can just uh, I can very easily mount it and dismount it from the chair. Just a couple of bolts hold it very tight, and it's really nice. Um, Inside the box, there is an Arduino Pro Micro, like this one, so, which is going to be the board that controls the well, everything basically. That is the board that you plug in to the computer, and the computer. These Pro Micro boards are gaming devices by default for uh, for Windows. So when you plug this in, without loading any code, anything, just plugging it, you can already see it as a gaming device in your uh, just device page in Windows. So we just need to load the firmware, which we will go through that as well. So don't worry. And you just need to tell the board what what inputs are we gonna have, like all the these are basically digital inputs. Every push of the button is a digital input, and then the analog inputs, which are the cursor and the the collective itself. There's also an analog potentiometer inside. Actually, I told you that this Arduino was inside the box, but it's not the case in this one. This board is actually inside this area here, and that is actually the probably the most difficult part of this build is managing to fit everything because it's a very tight space. Once you have everything wired, the most complicated thing is to close it together and make everything fit. I have built this is going to be my third collective. This is the second one I've built, and the two I've built it in two different ways, which I will be explaining. right away. But yeah, this one in particular has the Arduino Pro Micro inside here. The first one I built, it's inside the box, but that's a different one. And yeah, I will explain it later. As I was saying, this uses a potentiometer. This is a one-turn potentiometer. It means it does just one turn of the knob and stops. There's stops there. I think, I mean, this is really cheap potentiometer, and this is a very cheap and simple solution. Some people may argue that it would be better to use a Hall effect sensor, and you could definitely do that. The one thing I don't like about those, which is not a big deal, but is that for one, they are much more expensive. I think one of those costs around $15 to $20. This one may cost maybe $1 or something like that, $1 or $2. And the Hall effect potentiometers don't have stops, which can be a good thing and a bad thing at the same time. I mean, good thing is that you're not ever gonna break it. This one, if you push too hard, you could break it, but there's a solution in this build for that, so don't worry about it. And with Hall effect sensors, you don't have that, so they spin continuously, both sides. The thing is that they provide a value. I'm not exact. I have never used them. I think it goes from 0 to 1023. Maybe even more. I think they could be to 4,000 something. And then once you go past that point, it goes back to 0. But that can be a little bit of a problem to calibrate. But I mean, it's a perfectly valid option, and it's actually not that difficult. It's just I feel these ones are, as I said, much less expensive, and do the job just fine. Okay. Um. So what's the plan for today? I think today what I'm gonna do is I'm gonna be adding it's gonna be a simple video. I'm gonna go through all the materials that I've used, or at least the most relevant and important ones. Everything else will be displayed during the build anyway. If I miss anything, I will be speaking about it while I build it. But I'll go through the most relevant items that are going to be needed for this build. Hi, Cami. It's good to see you. So yeah, I think next step would be, let me just show you the materials, the main materials that I used. So you're gonna need, let me go back here. You're gonna need one of these boxes. The one that I've used and the one that I recommend, and the one you're gonna need if you're gonna use my files because they are for that size, is the 1590B, which is not this one, sorry. Which one is it? This one, 1590C, sorry. 1519C, you can see the dimensions here, 120 by 94 by 56. This is, let me show you. This is the one, right? You can see it comes with screws inside, and it's basically the one that I used. So 1590C. That's the box where the electronics are going. Actually, not that many electronics. In this build, only the potentiometer is going to be inside here. But there's sprockets and gears inside that are going to be in here, and obviously the friction ring. Then you're going to need a 30 millimeter tube. The one I used is aluminum, like this one. And it needs to be 30 millimeters outer diameter. And inner diameter, I've used in the past 20 millimeters, so the thick of the wall is 5 millimeters. But I think that's too thick. It's not needed to be this thick. So for this build, I'm going to be using one that is, I think it's 26. Yeah, 26 inner diameter. So it would be, you need to look for OD30. This is the one that I used. Yeah, OD means outside diameter 30, inner diameter, outer diameter 30, inner diameter 26. That's more than enough. It's strong enough. And the thing is that we are going to be drilling this tube and adding some threads to it because we're going to be using screws to hold it. So it needs to be thick enough to be able to thread it, the holes that we do. But as I said, the ones that I've used in the past, like the one that I have in already built, is 5 millimeters thick, and to my liking, that's too thick. It doesn't need to be that thick. Okay, and then we will be using bearings. This one is hold on, let me check which one is it. The one that I used. I don't remember. Yeah, 6806ZZ. So that would be 6806. Well, you can see because it gives you the oh 06. So this is the one that I used. You could use any of the two because the two have the same dimensions. It's just the bearing method. You could use 6806 2RS as well, but this is the one that I used. And these are basically 30 millimeters inner diameter and 42 outer diameter bearings. We're going to be using two of them. And a bunch of switches or different switches and buttons. We're going to need a few of 6x6 by 4.3 switch buttons, which are very cheap, are the smallest ones. The 4.3 are the smaller ones, these ones here. And then one of the bigger ones, well, maybe not the bigger, but biggest ones, which is a couple of 6x6 15 millimeters. Okay, we're gonna need a controller joystick. I like these ones, the older ones like PS2 or Xbox 360, because they are a little bit bigger. We'll be going over them, and I will be showing why I like them better than the newer ones. But I think you could use whichever you prefer. But I like these ones. They are also cheap and they work just fine. Then we're gonna need two 3-position switches. This is how I call them: three pin, 3 positions, whatever you want to call them, rocker switches. Two of them. One of them is going to have to be momentary, which is defined by this bracket. So when it says on, off, on, this means that the pole is in the middle, and whichever way you go, it has a spring that automatically returns to center. So we're gonna need one of those. And we're also going to need one like the one above, which says on, off, on, and one of them is in brackets, which what this means is that it's also a 3-position switch, so the pole is in the middle and goes up and down, but one of the positions, up for instance, stays up, and if you go to the other position, it has that spring that makes it return, and that is for the, well, I'll show you which one is that one is, but you will need one of these and one of these. If you can see here, the pole is round. You could use these ones. It's okay. It's not a big deal. But for the one that returns to center in both positions, so this last one, on, off, on, between brackets, which you can find it as mom, off, mom, and that mom means momentary, so that's a momentary switch. And So let me show you. I think, see, like this one would not be the one because this has only 2 positions. So in this case, you would have the pole to one side, and then when you would push it, there would be only 1 position upwards. So this is not the one that we need. We need this one here, mom of mom, momentary of momentary. And the pole is in the middle, and it goes up and down. And for this one, I preferred this version, which has a flat pole. And the reason for that is because this pole doesn't twist. It's not a very relevant thing, doesn't really matter because we're not going to be using a cap for this one. But I like them better. But you could use this. The thing with these round poles is that they turn, and if we were to use a cap inside, like stick a cap on top of it, uh, it could twist, and it's a little bit annoying. But we're not going to be using a cap for this build, so let me show you the build unit. This is I hope you can see it properly. This is this one. As you can see, it has a flat position, and as I was mentioning, this comes back to center, as you can see. But you could use a rounded one like this one. And this is the one, it doesn't really matter because we're not going to be using caps. And by cap, I mean like this piece here. We're not going to be using cap in any of those, so it doesn't really matter which way you go for the flat pole or the round pole. And this one is what I was saying, the one that has a fixed position on top, and then we go to the middle, and if we go down, it returns by itself to the center. This is how it is in the real thing. Okay. And I think that's, for the most part, that's the most important parts. Let me see. We're gonna need one of these. The one that I like is Type B, but you could use anything. I think there are also USB-C females as well, or USBs, whatever you want to use. You can use whatever. I like the Type B, which is this one here. Let me see. Which one is it? This one. This is the Type B. Because I do have other controllers like WinWing, joystick and throttle. I have a Warthog, a Thrustmaster Warthog that I modified to remove the cable and add this in the front, so I don't have to be plugging and unplugging cables. I just need one cable for everything, so that's why I went for this. But you could use whatever you need to. This is going to be plugged to the Arduino Micro. So basically, it's gonna be like an extension of the Arduino Micro port. And okay, so before we go to this part, let me go back to. We will see the camera feed. Oh, you're still saying, sorry for that. Okay, let me go back again then. So I was talking about these switches. So I think you already saw those ones, but I think the explanation is already clear. The other one that I was talking, the other piece is this. This is an adapter. Like basically, you can create an extension of the Arduino Micro port for this. So let me go back to camera, and basically, so you have a micro USB in this one. You can find them with USB-C as well, mini USBs. You can find, this is a cheap clone. It's not an original Arduino. This is a cheap clone I bought on AliExpress, and actually I didn't show that in the parts, and this is a very important one. But you can get this for like $12-15, something like that. Especially if you buy them in packs, like a pack of 5 or a pack of 3, it's going to be cheaper per unit. So what I was saying is that that piece that I was showing, this one here, hold on, this one here is basically an extension that we're going to be plugging to this port, because actually this one is going to be mounted here. So we need a cable that goes from this port all the way down to the tube inside here and to the port that we will be plugging to the computer, which is this one here. And as I said, you can use whatever port is better for you. Okay, so that's pretty much, I'm not going to say all for the parts, but the most important ones. And as I said, we will be going, you're going to need also a lot of, not a lot, sorry, a bunch of, I think it's 4 only of these push buttons. These are 12 millimeter, and the 12 millimeter is the diameter of the, let's say, the shaft. So the 12 millimeters is the diameter, the inside diameter. So the hole needs to be 12 millimeter. This kind of cover is a little bit, let me show you, a little bit more than 12 millimeter. I think it's 16 or something like that. So then you push them in and you need a hole, a 12 millimeter hole to fit these buttons. And of course, you're gonna need a whole bunch of 3D printed parts. You can see a few of them here. Oh, one other important thing that you're gonna need, sorry. Well, actually, you don't need this. These are, let me show you. These are custom PCBs for the 4-way switches, like these switches here that are 4-position switches. All these 3 are 4-position switches, and this one as well. So there are four position switches, sorry. And then these 3 here, these 2 are 2 positions. So this one is left and right. This one is up and down, and this one is up, down, and in. So yeah, forward, aft, down, if you want. So for the 4-position switches, I'm using this custom PCB, which makes life easier. You just solder, and we will be doing this today. You just solder these tactile push buttons that, sorry, I don't have here. Yeah, I have a couple of them here. So these are the 6x6 by 4.3 tactile push buttons. Then you put them like this and turn them. Let me show you. I have a magnifying glass. Let me see if this helps. I think it's better like that. See? And then you put 4 switches like this, and this will be the 4-position switch. But you really, and this is very inexpensive. I ordered 20 of these, which I don't need all of them. I just need it for other projects. You only need 4 for this project. There's a minimum of 5, but I ordered like 20 of these for less than $6. I think it was actually almost 5, not even 5, shipping included. If you don't mind it taking a couple or 3 weeks to arrive, and in the time you start building, you won't notice the time. So with the cheapest shipping method, this is not even €5 for 20 of this. So they are very inexpensive and make life easier for you. But you really don't need this. So the thing is that these ones, sorry, let me take the magnifying glass out. These ones that are 2 positions or 2 positions and down, do actually not use any PCB, any custom PCB. What they use is 3D printed parts like, let me show you one. This one here, for instance. I will be sharing all the files. You need 4 and another 4 if you are as clumsy as no. You do need to know a little bit of soldering, but not. I mean, it's very simple soldering what you're gonna need for this project. Sorry, the magnifying glass is moving a little bit. So you can 3D print these pieces. I think it's not looking very good because of the light. But this is just a 3D printed piece, and instead of using a PCB, what you can do, where did I put the button? Here. Okay. So instead of a PCB, what you do is you bend the legs like this outwards. See? And then you put them here inside. They fit tightly, and that's what you want. So you put them inside this case. Maybe I need to file it a little bit. There might be a barb, a rebarb or something. But this fit in here. Oh, actually the problem is that I was not, yeah, I didn't pass the legs through the hole, so I probably bend them. So there are two very small holes down there, you can see there, and that's for the legs of the button, so they need to fit in there. And I think I was not. Oh, there. You can see it now. It fits perfectly. And then the legs, you won't see it because there's too much light. Let me turn down the light a little bit. So the legs fit out there, and then you can solder the wires from there. This is a two-position one, and it's gonna be actually this is only a two-position. The one that uses the two-position plus the push is a very similar one. It's actually this one. But there are also options for four switches. So instead of being like this, it's like an X, and there are holes for four switches around. And you can use that instead of using this, absolutely. But these are very inexpensive, and to me, they help a lot, and they reduce the workload a lot. So that's why I'd rather use them. Okay, so what we will be doing today, oh well, actually, let me show you. There's a couple of other pieces that I want to show you. These are the pieces that are going to go inside the, let me take the magnifying glass out. These are some of the pieces that are going to go inside the box. I haven't printed the friction ring yet, but basically, let me, where's my X-Acto knife? So basically, we're gonna be drilling this box. This part here, the biggest one, goes at the bottom here, and it's a tight fit. Actually, this one is a little bit big, I see, so I'm gonna have to sand a little bit the bottom of it. This one will serve as a template to drill the holes, because we're gonna need to drill all these holes in the bottom. Then one of the bearings fits in here. We can put it already there. It's a tight fit as well. And then here in this slot here, we're gonna put the potentiometer. I believe I designed it to have the connections either down or up. It doesn't really matter very much. And then there is a bracket piece, which is this one. I'm gonna be sharing everything that holds it. And the reason I did it this way, sorry, it holds it like this, is because this potentiometer, and let's do that now, has a small sprocket that is friction fit in the, I don't know how you call this, in the pole. I call it the pole. It's tight, but it needs to be. Okay, there it goes. See? This part is already ready. We're not gonna taking this out. So this one here goes in here, and once we have the aluminum tube, this is a 30mm tube, and it's going to be cut at a distance. I don't know exactly the distance right now. I usually eyeball it when I have the box finished. So I put the rod like in here, and I say it needs to be almost like this, and then I will cut it. So we're gonna use the same rod, so you only need one for both this part here, which has you can see it a little bit showing up here, and then the rest of it, what's left over, is going to be. And actually, I think this is larger, this is longer than the one that I used in here. I think to recall, this is a 24 centimeter long or something like that, and this is a 30. So this one is going to be protruding in the back quite more, but that's okay. I mean, you can cut it or leave it. It's not gonna make any difference. So with this tube, with the shorter part of the tube that will fit in here, it goes this other bigger sprocket, which has a ratio that it makes that one turn of the of the potentiometer is going to be about 45 degrees approximately. So when we put this here, as you can see, we need to, well, maybe you can't, but the thing is that the potentiometer will be mounted here and this will be mounted here. And the reason I made this bracket and I made it a little bit in an oval shape is so you can slide the potentiometer sideways a little bit to make a tight fit with the other. So you may need to move it a little bit sideways to make a tight fit with the other piece. Also, I was mentioning that these potentiometers can be a little bit weak, and if you force them too much to one side, they can break easily. And this is not a very heavy handle, but it could still break the potentiometer. So this is why this sprocket has this shape, because this will be mounted in a way that this piece here will act as a brake against the side of the box. So that's what's going to be holding the pressure, not the potentiometer. And same for the bottom part. That's the box, and this piece is what is going to be holding the pressure. Then you can see I have this piece that I was showing before. This piece is going to be mounted here. I cannot show you yet how it's going to be mounted because it protrudes a little bit, but basically this PCB fits in this hole, and we are going to be drilling a hole in here to fit the outer case, so it's a little bit flush, maybe a little bit, maybe not exactly, but it doesn't need to be exact. It's going to be pretty much flush or flush enough. Yeah, we will see through that. And then this is the top part, which is going to go in the plate and in the lid of the box. And this one will also hold the second bearing. So we will have two bearings holding the rod. That way there is no friction against the aluminum case or anything like that, and it's nice and linear motion. So this would go like this. The sprocket will go inside, and in between the sprocket and this part here, there is going to be a friction ring, which I have not yet printed because this PLA that I use for the rest of the pieces is rather brittle. I think it's a cheap one, or maybe it's older, or I don't know, just drier. It's very brittle, and for these pieces that's brittle, I mean it's still strong, but it doesn't flex much. And for these pieces, that's fine, that's perfectly fine. And I printed this with a 50% infill, so they are very strong. They are not gonna break or anything. They don't need to hold that much pressure anyway. But for the friction ring, you want a tiny bit of flex at least. It's not gonna flex a lot, but it does need to not be brittle. So you can print that in PLA if you want, if it's not like I said, a brittle one like mine. Ideally, if you could print it either in PETG or ABS, that would be better. But I struggle with those materials a little bit. I'm not an expert with 3D printing, so I just print it in another PLA filament that it's a little bit more flexible, and that seems to work very well, especially with this one that I have a counterweight, and actually the friction ring is not that much tight. It's not tight. It does have a little bit of friction, but it's not much. So let me move this aside, and I think we can start building something. So for today's video, it's gonna be a quick one. The main part was explaining the materials and all that. We're not gonna be doing any wiring in this. Well, the only wiring that we are gonna be doing is, soldering leads to some of the buttons, but we are not gonna solder those leads to anything yet. So basically we are gonna be building, hopefully we'll see how long it takes. I don't want to bore you to death, but we will be soldering the top plate, which is this one here. So we will be soldering all the 4-way switches, and then there is a push button here and the joystick, which has this is like a support or a bracket, whatever you want to call it, to screw it in here. And yeah, probably maybe we can even do the trigger and these other switches here. So let's get to it and see where we get to. Let me move this aside, and then I'm gonna need probably some helping hands. Okay, so what do we start with? It really doesn't matter much. Let me see, what do I have printed here, because I think I'm missing one very small piece. Ah, no, there it is. Okay, so let me show you what I've already done off camera. I've basically printed for the grip itself, there are 1, 2, 3, 4, 5, 6 pieces mainly. So the two tops, so this is the mission grip top, and this would be like something like this, and this is the top, and this is the bottom top, or whatever you want to call it. It goes the other way, like that. So these are two pieces, and then this is the mission grip, this is the flight grip, and I printed them in half because basically it's a filament printer that I have. If you want the better finish and you have a resin printer, this, I think I have not seen it in person, but I've seen a guy in YouTube that prints like these ones, like in resin, and they look amazing. I am probably going to build one, but what I did is I printed them in half, and like this piece goes like this in the bed, and the other half goes like this, and same for this one with supports, obviously. And the reason I have already glued it offline is, once, because it's just gluing it. It doesn't provide any value that I do that online, that I do that live. But the other reason is that I had a little bit of a problem with warping, and I know PLA should not warp too much. This is the easiest material to print with, but as I said, I think I've used a cheap filament, and it warped just a tiny bit, not much, but it didn't. The seam was not perfectly flat, so I had to fill it with super glue. I have thick super glue. It's very thick one, so it can fill small gaps, and then sand it, which, by the way, sanding super glue is a pain in the ass, really. So I didn't want to do that. So basically I glued it together, I sanded and painted it. It does not look super good, but let's not forget that this is a DIY project. So we can't expect to be like out of a factory. It's always going to be, and actually the finish, it all depends on you. How long do you want to stay? What are your skills? What are your devices? What printers do you have? As I said, if you have a resin printer, you can print this in one piece, and it will look super awesome. If you have just a filament printer like me, I have an Ender 3, not even the Pro. It may not look as good, but you can still how you call it, sand it more than I did. I just did give it a light sanding, especially through the seam, and one coat of painting. So if you want to spend some more time, it's going to look better, but I really don't care. I just want it to look good. I just want it to work, and it does the work. I just noticed something. This one has a small crack in here. Sorry. Here, this is what filament printers do sometimes. So it's a little bit broken. So I'm gonna be adding some super glue here on the inside, so that's not gonna be visible. So let me just do that now. So the crack is here. This is one, and it's not gonna be seen outside. Well, maybe a little bit. Okay, some of the super glue squirted out. But as I said, I mean, this is the bottom part. The once the the collective is mounted, this is going to be looking down. So if it squares a little bit of super glue in the side, it's not that important. Just make sure this is strong because we're gonna be force pushing a button here. The hole is a little bit tight, so we may actually, yeah. So we may even need to sand around here a little bit, maybe, or maybe just force the button in. So you want this to be strong. There was a little bit of another crack, yes. Like I'm gonna reinforce this part here. There's also a little bit of a crack here. Okay. And as I said, this is the interior. It doesn't matter if it does not look good. Nobody's going to see this. And even outside here, there's a little bit of a super glue here. It doesn't matter. It's going to be looking downwards. Again, it all depends on what you want to do. If you want it to look perfect, just sand it. You can use like primer or filling putty or something like that. You can give it the finish that you want to. Okay, so besides gluing it together, I did something else, and I recommend you to do this. If you manage to print this, if you print it in two pieces like me on a filament printer and glue it together, if before gluing it you notice that the seam is very good, um, you don't have gaps, and when you glue it together, you're not gonna need to fill it and paint it, because this is black filament. If it was perfectly printed, you wouldn't need to paint it if you didn't want to. So if you see that you don't need to paint it, I would recommend adding these buttons, which for this one we're gonna use one of these yellow ones here. This one button here. There's also one small button. This is a 6x6x15 tactile push button that will protrude outside here. Let me show you with the magnifying glass. So here, this one goes inside here. And then in here we have the, which one is it? This one here, which will also come out of this one. I'm gonna have to put it from the bottom because I needed to glue this piece together. But if you can have this printed without needing to paint it afterwards, because as I said, you put the two pieces together and you see that when you glue it, there's not going to be a gap. I would recommend doing this before gluing it together. So add this button, add this switch in here, and also this button. This is not that important because you can reach very easily down here, but especially these two, and the one for the trigger, which is inside here, and you can see it here. You can see probably there is a button there. That's the button that is going to be the trigger. If you can put those buttons before gluing it together, that's much better. And that's what I did with this one. The other one, I didn't put the trigger button yet. So let me show you. There's the hole, but the button is not there. And I'm gonna have a little bit of a struggle to put it. I already know, because well, it's in a very weird position. I cannot reach easily, and also the space is really tight. Actually, I think I need to file a little bit the sides, and with this being already glued, I don't know how am I gonna do that, but that is probably one of the things that I will do offline. Next video there will be a button there. So as I was saying, I already added this button here, and it has the lead, the two cables. So let's start by adding these two buttons here, and probably even the trigger. I think it's going to be a good start of the video. So first thing we're gonna need, my helping hands. Let me move the light around a little bit. I'm gonna hold this maybe like this. I hope you can see it properly. Of course, you're gonna need wire. I didn't mention it, but I have this roll of ribbon wire, which has 10 individual wires. This is 28 gauge wire, but you can use thicker one if you want, 26. I wouldn't go much farther than 24. 26, between 24 and 28 should be okay. So I will cut, actually, yeah, I will cut, I just eyeball it. So this is going to be, just cut a piece like that. It's better to cut longer, obviously, than be short. So let me just, where do I have? I had some scissors and I don't know where I left them, so I'm gonna have to use the clippers. Okay, so I've got a piece of them and I'm only going to need 3 of them. Where did my button go? There. Let me just put it, let's see if it holds. Oh, in the meantime, let me just plug the soldering iron. I didn't have it plugged. Okay. I have a whole bunch of things in my table. Sorry about that. So yeah, as I was saying, I'm only going to need 3 of them. So I grab an X-Acto knife and separate them three leads. There you have. Then separate the 3 individual ones. Give yourself some room. It's gonna make your life easier. So I split them a little bit and then I pull them apart. And as you can see, I have plenty of room. I'm gonna even do a little bit more. And now, oh, holy shit, I do recommend you have one of these. I've been stripping wires with an X-Acto knife for a long time, like doing something like this and cutting the out of it. These are not silicone wires. Buddy boys, hey Gravelmon, how are you doing? Nice to see you. And that is horrible. That's the worst thing you can do. It's gonna your fingers are gonna hurt at the first one that you do. So get yourself some wire strippers. I was doing that because I thought these were so thin that these strippers wouldn't work, but they do. Once I realized they do, I was thinking to myself, you're an idiot. What have you been doing all this time? So just strip the ends of it. It's super easy. And my fingers are grateful that I realized this. Okay, just twist them a little bit. And then we're gonna hold this wire here. You need to have some basic soldering skills. I'm not gonna go through what you need to do to solder. This is not the intention of this video. So there are plenty of videos on how to solder on YouTube. So I'm not gonna be bothering you and wasting your time on that. So basically what I'm gonna do now is pre-tin both the wires and the pins of the switch. So a healthy bit of solder in the pins. Yeah, then pre-tin the wires. Just like that. And then, although it's not strictly necessary to use a shrinking tube in this because these wires are never gonna touch each other. The pins are solid, so they are not gonna cross or something like that. But I do like to use shrinking tube just to hold the wires. These wires, as I said, are 28 gauge and they are super thin. So if they wiggle a little bit, they will break off very easily. And I found that using a little bit of shrinking tube helps in holding those connections. So I will cut 3 pieces. Can you hear the music, by the way? There's a little bit of background music, but I have it very low because I don't want it to distract me. Actually. Okay, so let's remove this wire. And then it's just as simple as middle wire goes to the middle pin. There. And then side wires to the side pins. Oops, hold on. There. Come on. These helping hands are new, and I see that they don't grab very well. There. Just wait a second. There. And then turn it around. Come on. And solder. Wait a second. Okay, solid. So this is how it looks like. There. See? All 3 leads are soldered in, and then I just push the shrinking tube like that and apply a little bit of heat. Okay, good. No music? Oh, hold on. Let me see. Spotify, it should be on, but I can see it's not moving. Okay, maybe I lowered the volume too much. Yeah, I think you can hear it a little bit now, right? Let me know if it's too high. It's just meant to be background music. But I think you should be able to hear it now. Okay, so we have this one already. Let's put it aside. And the next one is going to be the 6x6x15 one. I like to push the legs in. So legs usually are like this. I push them in. So in case you didn't know, I mean, if you know a little bit of electronics, you will already know, but let me show you with the other one. The legs, there's 4 legs, but 2 of them are actually connected together. So these 2 that you can see that are let's say in parallel, you can see these 2 are the same piece. So these 2 are connected together. And then the other 2 are connected together. And when you push the button, what it does is connect this one to this one. So like in here is the top one connects with the bottom one when you push. Nice, thank you, Cami. Okay, but if you turn it around, these ones are already connected. This is one piece of metal actually. So what I do is bend them down and put them together, and it makes like a stronger, because once I solder them together, it makes a stronger fit. Hey, Kali, how you doing? We're building the collective. We're building this. So yeah, we just started, but don't worry. I will be posting the VOD in YouTube afterwards for anyone who wasn't able to see it. You didn't miss much anyway. We just started. So I'm gonna be adding leads to this button here. Let me just, how am I gonna do this? Maybe like this. You can see, let me add this. Got some helping hands there. Yeah, I do. Okay, so can you see how the button is placed? Like that. So I just, held it by the pole like that. Okay. I'm gonna add a little bit of solder to the leads. To the legs. And as I was saying, bending them like that solders them together, and it helps for a stronger connection. Because in here we won't be able to add a shrinking tube. We're gonna have to rely on the solder being a nice bit of solder holding the wires. Yes, I'm using an Arduino Pro Micro, like this one. And the good thing about these ones is that you can program them to display as whatever you want to call them. So by default, when you plug them in, it will say Arduino Pro Micro device. And because it's a Pro Micro, it will be already detected by default as a gaming device without not even loading a single sketch. But the good thing about Arduinos is that you can give the boards a name. And what I did is actually when you load the sketch, if you do it the way I am gonna show in a later video, it will be displayed as an Apache collective. It will be like, you know, when you have your Virpil pedals or whatever in the device manager, it says Virpil pedals, whatever. With this project, you will have a collective that actually says Apache or AH-64D collective or things like that. Do you have daughter boards and all that? What is a daughter board? So I just stripped a two wires from the previous, from the previous wires. So there's two here. I'm gonna split them as I told you earlier. So the Arduino is one board. Do you have any boards connecting to them? Oh, no. For this project, you don't need anything like that, like parent and child boards or anything like that. No. I actually failed to mention, well, I did mention that I built this in two different ways, but I didn't mention the other way. So one way that we're gonna work, actually, let me stop here because that's an important piece of information now that you mention. So we have, let me take this out. We have a lot of inputs in this collective. All of them work as I mentioned in the past. So there's 3-4 position switches here. So that's 12 already. There is a joystick. That joystick is 2 analog inputs plus a push button. So let's say 13 digital inputs. There is a push button here. 14. There is another push button here. 15. There is a three position rocker switch here. So what was I? 15, 16, 17, and then if you turn it around, you have a button here and a trigger. So only in the mission grip, there's what, 19 inputs, I counted? I don't know. I think it's 19. Then you go to the fly grip and you have also two trigger on here. So 2, you have the jettison button 3, chop button 4. This is a 3 position, so 5, 6. The middle position we're not using. Another 4 position, so that's 10. This is a 3 position, forward, up, and center. 2 position. So I don't know already. I have lost count. And then for the jettison button, I've also added a limit switch. I don't know if you can see it there. So you can map. This is the jettison lid. I just have it out because I want to paint it. But there is a lip. Let me see if I can show you. There is a lip there. You can see there that when it's closed, the limit switch is not actuated. But when you open it, that lip makes it so the limit switch is actuated. So there's also more inputs for the jettison lid. And of course you have the other analog input for the collective itself. So yeah, as I was saying, it's I think 30 something digital inputs and then 3 analog inputs. And of course, an Arduino Pro Micro doesn't have that many pins. So there's two ways, and I have actually built, as I was saying, that I built two collectives, and one of them I built it one way, and the other I built it the other way. So I have tested the two options, and the two work fine. So the way we are going to build this one, we won't need any child board, as you mentioned. It's going to be only using this, and of course all the buttons, potentiometers, and whatever we need, but there's not going to be any other board other than this one. And the way we are going to be doing that is with a matrix of button. So let me show you how a matrix of button works. Just give me a second. Just a second. So I have one of these keyboards for Arduino projects. If you can see here, this is a 4x4 keypad. That means it's 16 buttons. There are 16 buttons here. And of course, you could plug each button to one pin of the Arduino. But it doesn't actually, I don't know if you could. Actually, it has, yeah, I think you could. It has just enough if you took all the pins. I don't know how many pins. I think it has 18 pins, the Arduino, including the analog ones, which if you don't need them, you can use them as digital. But you can use 0, 1, sorry, TX, RX, you can use them as pins, then 2, 3, 4, 5. Oh, you can see them. Hold on, let me see. You can use all these pins as individual inputs. Just find it fascinating. So the Arduino is one board. Do you have any board? Oh, okay. No. Please just interrupt as much as you want. That is the intention of this stream, to teach you how to do some of the things. So yeah, so as I was saying, you could plug each one of these buttons to one input, each one of the Arduino, but you would run very quickly without pins. So what you do in these cases, and this is actually what it does, you can see here that this keyboard only has 8 pins. 8 pins. There is only 8 pins here, and you may say, so there's 16 buttons. How is it possible that there are only 8 pins? And this is because if I turn it around, let me show you. The light is going to be in the middle. Let me just move it away. This is a matrix of buttons. And basically what it does is that we only use one pin for each row and one pin for each column. And whenever, so basically Arduino scans all the rows and columns. I'm simplifying this a lot, but basically what it does, exactly. So basically it checks all the columns. Well, actually what it does is turns high, for digital inputs, we have high and low. So turns high each column at every time, and then scans all the rows and see if there is one of them that is high. And by matching in which row and in which column we are, you can see which is the button being pressed. The good old Christmas lights series. Well, yeah, I mean, matrix of buttons can be a little bit complicated because this is a very simple one. And basically, as I was saying, it's hard to explain, but basically, as I said, it's turning on each column at once. So basically, Arduino says, okay, I'm in column 1 now. Let's say column 1 is this one. What happened? And this is high. No diodes, interesting. Well, that's what I was going to mention. So if you are going to press only one button at a time, you don't need diodes. So if I only press 5, it's okay. If I only press 9, it's okay. And Arduino is going to be able to identify what's being pressed. Now, the problem comes when you do need to press several buttons at once. And for this project, we are going to need to do that because for instance, this switch here, which is a latching switch when on top, that is a button being pressed. Now, if I need to press another button like this one or whatever other button, it might not happen anything, but it may as well, because the way matrix works, it could be getting a wrong reading. Don't make me explain you the details, because I'm not. I mean, I do understand it, but it's very hard to explain. But the thing is that if you need to press several buttons at once, you will probably want to add diodes. Exactly. That's being pressed and held. That's the same. That is the same as me doing in this push button, which is just a push button. Push and hold. And as I was mentioning at the beginning of the video, I'm using the triggers as modifiers. So for instance, all these buttons are mapped to what they actually do. So most of them are not in use. Many of them are for FCR, which is not yet in use, but I do have them mapped for that. So basically each button does what it's supposed to do in the real thing. But I also want to except the triggers, which I mentioned triggers is to activate the books, which is never going to be anything in, because it's a physical thing. It's never going to be implemented in DCS. So I use them to as modifiers. So if I press the trigger and another button, then it does something like F10 map or turn on the idle of the throttle or things like that. I did see the FCR video, yeah. Looking forward to it, but I'm really not that good with the Apache yet to know how well I will be with it. But anyway. So, okay. So, yeah, what I was saying is that we are going to need diodes for this project. But I will be explaining that when the time comes. So, yeah, let's continue where we left it. Oh, actually, hold on. So that is one solution. Another solution that does not include or imply diodes is to use port expanders, and that is, let me show you, this one here. This is a PCF 8575 port expander. You have 16 inputs and you only need 4 pins. The interrupt one, you don't need it. So you only need 4 leads going to the Arduino board. So this would be an example of building it with child boards, as you mentioned. So a parent board would be the Arduino, and then several child boards. And for this project in particular, you would need 3 of them, which you can daisy chain. So there are still 4 leads only going to the Arduino. So you daisy chain them. You give each one of these boards an address, and they connect via I2C. And the first one that I did it this way. So both ways work. For this one, since you are going to be using 1 pin for each input, you will not need diodes. You would not need diodes. You would just plug in each button to each input of the boards. And as I mentioned, you're going to need 2 of them full. So that would be 32. And I think you need like 6 more pins, 6 or 7, 8 more pins. So 3 boards you would need. Or you could use 2 boards, and then because this would be plugged to VCC and ground to the Arduino. Hold on, let me show you. If you did it that way, you could actually use only 2, and maybe I'd reconsider and do it like that. So those go to VCC and ground, so those are pins that are not input pins, and then to pins number 2 and 3, which means that you are left with a whole bunch of other pins. So for those 6 left that are left to, I mean, those 6 inputs that are left, you could actually plug them directly to the pins. So we may consider that, because those boards are very inexpensive, as you can see. I bought, I think, 8 of them for $1. Your channel to the Apache project. Could be. I don't know. Well, you weren't here from the beginning, but this is what I showed that we may do someday, and I think you're gonna like this. We may do that someday, but that's a little bit more work. Yeah. Anyway, so yes, I was saying I was thinking of doing it with a button matrix, but I think using these boards is going to be easier. So I might change my mind and switch to this option as well, because with this one we don't need. Yeah, it's a lot of printing. Only the case took like 2 days and a half. So yeah, but it's a really nice project. PLA, yes, but you could print it with whatever you want. Okay, let's go back to soldering for now, because nothing is going to change for now. Nothing is going to be different whether we do one way or the other for now. So we were soldering this small push button. I probably lost my wires that I had prepared for it. Where did I put it? Yeah, they went to the 9th dimension, so I'm gonna have to cut others. Where did I put them? Anyway, just let me cut two others. uh, if you ever get to soldering a little bit, even as a hobbyist, I just do hobby projects, you will eventually burn your hand. It's not a matter of whether you do burn them or not, it's a matter of when. You should see my table right now. It's a complete mess. I can't find anything. I have everything spread around. Okay, so basically I'm splitting these two leads apart, then strip them a little bit. I've already pre-tinned the buttons, so I'm gonna pre-tin the wires now. And remember, this is a 6x6x15 button. It looks like this. It has a long how you call this, pole, whatever. I mean, it only needs to melt solder. So how hot is your hot iron? I mean, hot irons are for that, to melt solder, aren't they? This is a very simple one. It's not nothing too fancy. You don't really need too fancy tools. So let me put this so you can see. And I'm gonna be just soldering this like that. It doesn't need to be pretty, as long as it makes a good contact and it's strong, so it doesn't strip the wire. Let me just grab this. Okay. If anyone who knows what they are doing with soldering is looking at me, it's gonna be cringing. Okay. Okay, so now we have the leads soldered to the button. We can like fold them together a little bit so they go down. And then we can grab the, let me move this aside, the mission grip, and we are going to be adding this button here from the bottom, and the switch is also going to this hole here. So let's do probably the small button first. And what I will do, it's just held with glue. So I don't know if you can see it, but there is yeah, you can. So there is a box there, and that button fits there. So what I'm gonna do is just put a little, actually, no, let me just put the button first. So just, thread it in, push it in, and you can see it's protruding a little bit. Just click and feels that it clicks okay, and it's perfect there. See? And then I'm gonna add a little bit of super glue to hold it in place. And this is a DIY project, so there is a lot of super glue involved in it. I have a very thick super glue, so that also is useful for filling gaps or that's a complicated movement, sorry. I know you can't see it, but I'm just adding a little bit of super glue to hold it in place. And there. A little bit of accelerator, and the super glue should dry very quick. There. So now I click. It's perfect. Yeah, that's perfect. You can use hot glue. The good thing about hot glue is that you can actually remove it very easily. Okay, so now we are going to be adding this. It doesn't matter which way we put it, but I think, yeah, you need to add one nut. This comes with 2 nuts. This is like a holding plate or whatever you want to call it. I don't know what's the name of it. This 2 nuts, and one of these. This is to avoid the screw from coming apart. So you add 1 screw at the very bottom. Yes, that's true. It would be more complicated. It was a little bit complicated too, and that's the thing I mentioned before you came in. This is a two-piece print. Hold on. I glued together before adding the buttons because I had a little bit of a warping issue, and I had to add a little bit, fill in a little bit the space with super glue and then sand and paint. And it's better to do that without the buttons because you would paint the buttons otherwise. But if you had a good printer and the seam was nice and flat, and you thought you wouldn't need to sand and paint. If you don't need to sand and paint because the seams are good enough and are flat enough, then I recommend to do this obviously when it's split apart. It's gonna be 10 times easier. But still you can do it like this. So let's now add this. Next part is this one here. It has a groove. And then let's fit it in. I know you can't see it, but I'm trying to fit in the switch. There. There. Okay, let's just hold it. Then use this nut. Well, it's not a nut, it's a washer that holds the nut. Then slightly fit the nut if I can. And this is easier said than done. There. It's just, okay, it's just started. Let me just grab, I don't know how you call them. This. I don't know how you call them this. How long have you been doing DIY tech? Hi, Zoe Birdie. Quite a long time actually. I'm really into electronics, and I've been doing button boxes. I've been doing so. Actually, that's probably one of the next projects I'm gonna be doing on stream as well. Is maybe button boxes or even I think the next project actually is going to be what is it? Track AR, a battery powered track AR is really nice. Super inexpensive. Is it this one? Yeah, this one. So basically I just grab, how do you call this? I don't know the name. And tighten it by hand. Actually, I don't think if this one is actually gonna be too big. I think it's gonna be too big, so I might probably have to, let me see. Oh no, it was the wrong size. Okay, this one is the right size. I just tighten it by hand. It's not gonna hold too much pressure. Yeah, that's the best thing. And it uses a, actually I have the battery I'm gonna be using for that project here. It uses a battery that is 1200 milliamp hours, so that's gonna last forever. You're not gonna be playing that long. So yeah, this is, I think, tight enough. Tightening it by hand is enough, and now you put your hand in the grip and check that it has the proper feeling, and it does. It's perfect. So we have now this button and this button here. You ended up just buying one. Yeah, well, I mean, even if you buy the AliExpress ones, those are about 100 and something. I mean, the track AR one, the original one, I think it's $180, something like that. And yeah, I mean, it's easier. You just plug it and play. There's a lot of documentation about it, but I'm all in for cheap or free stuff. So I just decided to build mine, which I used to sell them, those track ARs, I used to sell them for about $30 to $40, including the webcam that you need for that, because you need a special webcam. So you can imagine if I sold them for $30 to $40, you can imagine how much the actual cost of it is. So exactly. And not only that, I've tried different cameras, and not all of them work the same, even if you remove the filter. And when I do the series for that, I will very strongly recommend to use the PS2 camera. Sorry, PS3 cameras. Head tracking really that good? I mean, what do you use if not head tracking? One or another. I'm currently using, because I don't usually fly in 2D. I usually fly in VR, but I do sometimes fly in 2D, and I currently don't have an LED track AR. I have that program, which is also free, that tracks your head movements, like tracks your eyes and all that. And so I don't have a device attached to my headphones or anything like that. And that works fine. Oh, Zoe, you are about to discover a whole new world. Yeah, absolutely. You need to download a program that it's called my webcam, but it was really shaky. Well, you need to set it up, but it really does make a difference. I mean, we've all been in that situation of flying with a joystick, like for the camera, but it's night and day, really. You probably just need to set up your curves in the tracking software, but it's definitely worth, absolutely. 240 gigahertz. Well, yeah, DIY one is not going to be as accurate, but I think it does the job just fine, and it's going to be a fraction of the cost, definitely. Okay, so now let's gonna, you know what? We could do this, but I think I'm gonna do the trigger first. It's a little bit more interesting part to do. This one, as you can see, it's just a button like this one, and it's right there, so there's not gonna be any complication to it. So let's just do the trigger first, because it has a little bit of trickiness. As I mentioned before, for those who weren't here, I had already, before gluing it, I had added the button here. It's one of these, let me find it. One of these small tactile buttons. This is a 6x6x4.3 tactile button, and it's inside there. You can see it there, right? And the leads come from behind. Those are the leads for that button. So basically the trigger, which is this here, goes, let me put this out, goes like this. Hold on. I might need to file it a little bit. I think I need to file it a little bit. Yes, it's not fitting in. But basically, it goes inside here. Oh, might not. Okay, I think I don't need to file it. And then when you push it, this lip here is the one actuating the button. So let's do that. To hold the trigger, let me show you with the magnifying glass. There is a really small hole over there, and there's these lips here. You need to use a piano wire like this. I have some. This is used for RC and things like that. And I think, let me check, but I think this is a 1.2 or so millimeters piano wire. So this is a, yeah, 1.2. I think it's, yeah, 1.2 piano wire. So what you would do is it will go from that hole in the outside through this piece here, through the trigger, and until the let's call it, this is the left lip, and this left lip doesn't have another hole in them, so you just push it all the way through, and you need to measure it. So what I would usually do is feed it through the first time because it's a little bit tight at the beginning. Well, not the trigger is quite easy, but this one is a little bit tight, so I would feed it through a long, I have a long piece here. You can see it's a long piece. I feed it through a little bit. I might have to wiggle it a little bit, so I do just like this. Let me just turn it around to make sure it fits properly. There it is. It went through a little bit now. Now it's trying to get into the lip, as you can see. Just wiggle it a little bit. This one is one that I had laying around, so it's not perfectly flat. Let me see if I can flatten it a little bit. Yeah, should be okay. Sometimes you are actually, because the hole is so small, sometimes the prints, are not that accurate, and you are essentially drilling the hole again. Just make sure before trying to, cutting it to size and adding the actual trigger, make sure that it goes all the way through, which it's taking me a little bit now, but eventually we'll make it through. Hopefully. It's taking me a little bit. There it went through, you see? So now we want to go to the other one and make sure the hole is properly aligned and properly, you see, we align it and we make sure that the wire can make it through because we want it to be held properly in both sides. Okay, so now that I have it through, I know the wire can go through and all that. Basically, you can see, what I'll do is maybe mark it. I don't know if I'm gonna be able to mark this wire. Let me see if I can mark it. Yeah, I think it's okay. It doesn't matter. Actually, I would recommend cutting it just a tiny bit longer, a very tiny bit. You're gonna push it with pliers anyway. Okay, so I have the mark there. I don't know if you can see it, but yeah, I have the marker there. So I'll cut it to size a tiny little bit longer, but not much. There. So that's the piece that we're going to be using. And now there is the most important thing you have to bear in mind for the build of the trigger. I've done this collective twice, and I've done this mistake twice. So learn from my mistakes and don't do it. I added the trigger. I put the trigger in place, and 2 times out of 4, there are 2 triggers, so I've done it 4 times. So that I put the trigger like that. And can you notice what's the problem with that? make sure you put the lip inside. Really, it is important, the lip inside. And then actually it's better even to fit it from the inside, the trigger. So you fit it here, make sure the lip doesn't go through, okay? Fit it from the inside and hold it in place with your fingers. And then it's just a matter of threading the rod in again, this time for real, because this is important. Yeah. So actually what I had to do when I did that, I had to cut this with pliers and reprint it again. Yeah, it's always the simplest. Yeah. Well, but thankfully I just had to reprint the trigger, but I did have to break it, because once this rod is in, it's not coming out. It's gonna be almost flush with this hole, and there is no space anywhere. There's no space to pull it out. Maybe someday I'll modify the the design to put a screw instead of a piano wire, and that way you could take it out if you need to. That would be the better solution actually. It's just that the design I have currently is like this for now. So once this rod goes in, it's not gonna go out. So make sure you put the trigger properly. So now we will get our pliers and push it through. And I don't see much, so let me put the light the proper way. Okay, I think it's in the trigger already. Yes, see, it's coming in. There's still a little bit to go, but it's already inside the trigger, and it's about to come the other way now. So we need to go all the way through until we know for sure that the other end has fed through the left lip. So I'm sorry if I'm not giving you proper angles, but I do need to make sure I fit it through the proper way. Let me just take this out. This may require a little bit of wiggling, wiggle. There you go. I think it's almost in. It went pretty much all in. Just push. Yeah, now it's all in. Okay, you can see that it's barely protruding anything. If I needed to take that out, I would not be able at all. Absolutely, it's barely protruding out. Okay, so that means because we measured that rod, that means it's all the way through, and actually I can test it. So it's moving properly, but it's not wiggling sideways, which would indicate that it's not properly. If it wiggled this way, it would mean that the other side is not properly engaged. That's a good question. So this is PLA. Let me show you actually. This is the built one. And you're asking if this is strong enough. I would say it is. This is not really heavy. It's very light actually. It's all plastic and a couple of buttons, so there's not much weight to it. But it is true that it can have a little bit of flex. Let me show you with a little bit of light. It can have a little bit of flex, but it's not noticeable. I just super glued the two pieces together from here, and then this piece here, which is the, let's call it the bottom hat, has a hole here to hold it with a screw. Let me see if I can show you. So there is a small screw there that holds the top and bottom part together, and then there's super glue here. That's, I would say, plenty of strong. Of course, you're not gonna be beating this. Thank you. You're not gonna be beating this against, the wall or something like that. I do have it in a way that I mount it and dismount it every time I'm gonna play, because I have this quick release points. I just hold it with two M4 screws to my chair, and I just use it when I play. So I do manage it a lot, and nothing has happened so far. Okay, where were we? So we already have the rocker switch in the side. Sorry, the rocker switch in the side, the small push button, and the trigger. And we push and make sure that the trigger engages the small push button that I showed earlier here in the back. Um, you actually can't do that unless you give it a little bit of a shape, because as you can see, it's not straightforward. So there is not a straight path this way. But really, it does not need it. Honestly, I've been playing with mine for a while, and yeah, you're not gonna be janking this super strong. It's a precision tool more than it doesn't need to be super strong. Obviously, if you were to smack this against the floor or something, then you would have a problem. But that's not what the intention is. Also, if you print this in resin, it's going to be a little bit more strong probably. Yeah, it is very stuffed, and it's gonna be really worse. Actually, I mentioned earlier that that's the worst part of this project is getting it, closing it. Once you have all mounted, the most difficult part of it is actually closing it, because there's so much stuff in there that it's hard to close. Okay, so now I can see that the trigger is engaging the button. Just so you know, there is this hole here, is a small recess in the trigger that is going to contain a spring. That's actually what's going to give the trigger the strength to return back to its position. And that spring will hold into this part here, which is uh, the support for this button here. We will be doing that. So this basically aligns, when you close this button aligns with the trigger. So once we close this, the trigger will engage with the spring, and then it will return to position. So I think we can put this aside for now. There's only this button to add, but this is a very simple one, as I said. So we can do that later. We are gonna move to this. And what time is it? Okay, it's almost 2 hours already of stream. I think I'm gonna end this stream by adding this button here, which is a small push button like the one we added, 6 by 6 by 15, which fits in here like this. Let me show you. See, and then the rod protrudes outside. And we are gonna be also adding the joystick part, which is this one, comes with a support that screws into, well, actually it screws into with the with the joystick in, obviously. So it will come out like this. I hope you can see. So let's do that. First, the easy stuff. That's gonna be the push button. As I mentioned, I like to push these leads in. We're not gonna be soldering them to a PCB, so they don't need to be out. Just push them in like that. Let's grab the helping hands and solder a couple of leads to it. Just eyeball the. I usually eyeball the wire. This wire that I cut earlier, for instance, if this button is going to be almost here, this is going to be a short one, because we want plenty of wire. And as you can see, there's not much. So I'm gonna cut a longer piece of wire. Just, go big, and then you can trim it afterwards. So I'm gonna do, what's this, about maybe 30 millimeter, sorry, 30 centimeters, maybe 25, I don't know, but just go larger, longer rather than short. It's better to be long than to be short. That's what she said. So I'm gonna use two wires that I'll strip out of this flat cable, split them together, apart, sorry. I hope you can see all that I'm doing, and if not, feel free to ask me. Also, this is going to, I mentioned already this several times, this is going to be a series. We're not going to be finishing this today at all. We're not going to be any close to finishing today. But I do not want this to be a super long series, or at least episodes. So my expectation and my intention is to have this finished by the end of the year at most. So it's not going to be like months and months. I'm going to be probably finishing soon this stream, but I do expect to continue probably sometime this week. Also, I will be uploading this on YouTube, so anyone who wants to revisit the video afterwards, you'll find me. You search for Señor Socio, SR Socio, and you should be able to find me, I think. I will put links in my Twitch profile as well. There you are. So now, as you can see, we've soldered the two leads. Same as before, we're gonna bend the wires in a 90-degree angle so they come from the bottom. Let's take this out and then grab this piece here, and from the bottom, as I mentioned, we have a slot to fit in the button, just like before. So see, it fits in. We make sure that it comes out enough, that it clicks properly, and it does. So we're just gonna add a small dab of super glue there. And I say a small one because before adding super glue, let me show you. On top of this piece, we're gonna be also gluing another small one, which is this one here. And this one basically is kind of a lid of the button that will cover the button, but basically the most important one is that it has that round dome, small dome on top of it, and that's what's gonna hold the spring for the trigger. So let me do that now and show you. I will just add a small glue, and actually I can do two things together. So I'll add a little bit around. This piece has a little bit of an opening for the wires, so that goes to the bottom to let the wires out, and then glue it together like that. I hope you can see it. If I can add a little bit of accelerator. See? And that's how it looks like. Well, I'm not gonna edit the video. I'm too lazy. So it's gonna be a really, really long YouTube video. So anyone, I don't know if it's worth doing, chapters or anything like that in YouTube, but anyone can go and revisit it and go backwards and forwards if needed. So now I'm gonna be adding and super gluing the spring here. It's easier if it's super glue instead of just held with pressure. So basically I'm gonna super glue this spring here. And just for reference, this is it's 7 millimeters diameter, and in length around 20. Yeah, 20 by 7, more or less. There must be standard probably. I have this in an assorted of springs, and this is 7 by 19. Yeah, this is the one. 7 by 19. It's probably standard. So what I'll do is just add a little bit of super glue here. We only need to super glue the base of the spring, obviously. So it's held together. Add the spring. So it holds like this. A little bit of accelerator. Yeah, I might do it, but I tend to procrastinate a lot, so who knows. And now, as I mentioned, when we have this finished, I'm just going to show it now so you can see it, but when this is finished with all the buttons in here, we will fit this spring in a way that it matches with the hole there. And then, let me just put the wires inside, fit the wires through. So there will be a whole bunch of wires coming out of this, but anyway, it's not complicated to do it. So you feed it with a hole, align it, so it doesn't move, and now you have a springy action. It's perfect. Okay, so next and last one is the joystick. This one, I'm gonna actually modify. I modified this bracket because this joystick has some support legs here, there, so it doesn't go all the way through. And this would be useful if they went through and you could bend these legs down to hold them in place. So I've modified this, but since I had this already printed, I'm just gonna use it and snip the legs off. So I just grab my snippers, cut the legs, and if you have to do this, make sure not to cut the pins. So this joystick, it has two potentiometers. This is a potentiometer. This is another potentiometer. Let me show you. Potentiometer with 3 legs, potentiometer with another 3 legs, and then a push button with 4 legs, which again, 2 of them are connected together. So if you need to cut the legs, make sure just to cut the legs, not cut the potentiometer and the button pins. So basically, what I need to cut is this, which is just structural. These 4 legs. Okay, so we end up with the 3 legs of each potentiometer, as you can see, 3 here, and the 4 legs of the button. Now if I put this in the support, I can fit, hold on, let me just bend this a little bit inwards. Now all the legs, I hope you can see it, it's a little bit annoying the light, but the legs fit through the holes. Okay, so we are gonna wire that, but to avoid melting the support, I'm gonna wire them outside of the support. So basically, I'm gonna need my helping hands again. Have you taken apart any other joysticks to see how they do it, or this is your own design? Neither nor. I have disassembled the Warhol Thrustmaster joystick, but was not to see how it was done. But I was inspired by other designs online of essentially the two-stage trigger for other items. This project does not need a two-stage trigger. It's a single stage, meaning that it's only one click. So you only click once. There are some projects that I've done that require a two-stage trigger. So one click and then second click. And for that, I did need a little bit of inspiration. But it's basically my own design because I only took inspiration. I actually designed something that I liked it better. So I'll show you that in a later video probably. So now I'm bending the push button legs the same way I did it with the other ones. As I mentioned, these buttons have two legs that are common. So these ones are connected together and these ones are connected together. I don't know if you can see that. So when you push the button, what you are actually doing is connecting the left one with the right one with the left one. So these two are always connected together. So that's why I always bend them down and solder them together, the two leads. So let's do that now. I have this long wire that I cut earlier, about 25, 30 millimeters long. So I'm gonna need two leads for the buttons, and then we'll go with the potentiometers. So first we're gonna do the button. Let's cut two leads. There. Okay, so let's pre-tin both the button, there's only one button in here, so the button and the leads. So just if you want to see what I'm doing, but it's just basic soldering, pre-tinning the wires. And then also tinning the button. A nice healthy blob of solder. Okay. So now we can solder the leads to the button. There you have it. And now what we need to do is solder the potentiometers. And I need to explain you a little bit how potentiometers work. All potentiometers, all the ones that I know, I mean, there might be others more complex, but basically everything works the same. So we have these small potentiometers in this joystick. We will use this potentiometer for the collective itself. If you notice, all of them have always three leads. Even if you use a Hall effect potentiometer, will also have three leads, and the leads are basically one positive, one negative, so positive, ground, and signal, basically. And unless it's indicated otherwise, center will always be signal, and then the positive and the negative, it doesn't really matter. I mean, you can have positive to the left, and then negative to the right, or the other way around. It doesn't really matter. It will just the difference is that if you do it one way, you will have, for instance, the analog signal will be from 0 to 100. If you turn this potentiometer, as you can see, this turns. I don't know if you can see that, but it turns. So from 0 to 100, in this case, this is a center potentiometer. So it's actually positioned at the 50% position. So you would go one way to 0 and the other way to 100. If you plug it the other way around, the only difference is that this way will be 100 and the other one will be 0. So it doesn't really matter which way you plug in the positive and negative. So all potentiometers will need ground, signal, and positive, or positive, signal, and ground. And since we have two here, what we are gonna do is daisy chain two of these leads of the positives and then a wire coming out. So we only have one wire for positive and one wire for negative coming out, instead of, you know, soldering three leads from here, and have 6 wires coming out. instead of 4 that we are only half. So let's do that. So to do that, I will cut. We are gonna need. There's gonna be 4 wires coming out. 1 ground only, 1 positive only, and 2 signals. 1 signal for this potentiometer, 1 signal for this potentiometer. So let's do that. I'm gonna grab the same wire that I used before, the 25, 30 centimeters long, and cut 4 wires I need. So let's do that. I'm gonna grab brown. I have available brown. Let me show you. Brown, red, orange, and white, which is perfect. I can use brown for ground and red for positive, which will be 5 volts. And then orange and white will be signals for the 2 potentiometers. So let's split that. And we will split them rather long. So we want a lot of room. You can see I left quite a bit of wire split because we are going to be daisy chaining this. And in this case, we will need to include the support already. So let's grab the support, feed this wire through the button hole, which is the square one here. And what we will do is, instead of putting it already together in here like this, we will just leave it hanging. And we're gonna need, let me see, how are we gonna do this? We will need one of these. Let me see. I think what we will do, yeah. So we have brown and red. And since we are gonna daisy chain them, let me open up a little bit more. I'm gonna grab the cutter and very carefully cut the insulation plastic without actually cutting the wire. So once I have a little bit of a cut in the wire, just pull from it, see? And we expose the wires. So we expose a little bit more of the wires. Just bend it like this and twist them. Okay. We're gonna do the same with the brown one, which is gonna be the ground. Very carefully, not to cut the wires, just the insulation. Pull, and there it is. And again, bend and twist. So this is a good moment to pre-tin both the ground and positive wires and also the 6 pins of the potentiometers. So pre-tinning ground and positive. Now I'm gonna pre-tin the 6 pins of the potentiometers, just a little bit of solder. Oops, those ones bridge. Just there. Had a lot of solder in the iron tip, so let me just remove a little bit. Okay, that's gonna be good enough. Okay, so now I'm gonna grab the wires, the positive and negatives, and let's see how I'm gonna feed them through. I'm gonna feed them through this first hole here of the case, and we may need to strip a little bit longer. And what I'm gonna do is I'm gonna add a little bit of shrinking tube. And I don't know if this size is gonna be okay or I'm gonna need a bigger one. Let me see. I think this is gonna be a little bit too tight, but I like it. I prefer it tight. Yeah, I'm gonna use this size of shrinking tube. Choose whatever you see you will need for the wires that you use. But I like it. Well, actually, let me use a bigger one. I think I prefer a bigger one. So I'm gonna cut some pieces of shrinking tube. There. Positive. Come on. Doesn't want to go. Ah, I need to split them apart a little bit more. Okay. And then negative. And with these wires fed in through the hole already, I'm going to solder negative to one side. Okay. Hope you can see that. And positive to the other side. So in this case, it doesn't really matter, but I'm soldering the positive, which is the red one, to the top pin and the negative to the bottom pin. Pull back the shrinking tube, and with a little bit of heat, we shrink it. Be careful not to burn the wire or the plastic, and to melt it. And then we will also feed one of the signal. In this case, I'm going to be using the orange, at whichever one. It doesn't really matter at this point. So let's put in this analog, the signal wire, add a little bit of shrinking tube. And I'm already foreseeing a problem that I'm gonna have, but we'll address that soon enough. And that is that the hole for the wires is very small, and probably with all this shrinking tube, it's gonna be a little bit hard to fit through, but we will make the hole a little bit bigger. So pull down the heat shrink and shrink it. And remember the signal, oh, actually I made a mistake. I'm an idiot. So I didn't fit the analog. I didn't fit the analog wire through the hole. Let me cut this shrinking tube. I might be able to pull it out. No, I'm not. Okay. It's always the small things, as you said. Okay. So basically, I forgot to fit the analog wire through the hole in the case. So let's do that now. Let's put the shrinking tube. And solder it again. Okay. Shrink it. Okay. And now what we're going to do is the other potentiometer for the x-axis or y, whichever was the other one. We're going to pull the, the, the leads that we left from ground and positive. And I think this is going to be a little bit too tight. So maybe, let me see if I can. Yeah, this is going to be a little bit tight. So we pull the wires a little bit and let's see if we can get, it's gonna be short. Okay, let's go another route then. What we're gonna do is, for now, we're gonna solder the other analog wire first. So the pin in the middle, I've already fed it through the hole. There. And then need a little bit of shrinking tube. Yeah, that's a lot of, I had a blob of solder in my tip. And let's see if I can take out a little bit. Yeah, that'll do. Okay, pull down the shrinking tube, shrink it, perfect. And since I left the two leads for ground and positive too short, what we're gonna do is solder two smaller wires. Let's see if I have some spare ones here. I guess I can use this one here. I have a piece of wire here. We're gonna take two of them. So we have two wires here, yellow and green. It doesn't really matter the color. Where's my X-Acto knife? Here. Split them apart. Just a little bit, doesn't need to be much. Okay, where's my, here. Pre-tin them a little bit. Okay, feed them through the hole. Let's split them a little bit more to give us some more room. Little bit of shrinking tube. And one side. It doesn't matter which one. And the other side. There you go. Pull down the tube. And once again, shrink it. That should be okay. Okay, now we can pull all the leads out and place, let me take this out for a moment and try to put the, yeah, see what I meant? There's so many wires, the hole is so small, and with the shrinking tube, it's not gonna fit through. So what I'm gonna try to do with an X-Acto knife, and hopefully without cutting the cables, I'm gonna make this hole a little bit bigger. So I push all the wires to this side, and I'm gonna try to cut this side a little bit open. And as I said, I hope not to cut any cables in the process. I just made these holes too tight. Didn't have the shrinking tube into consideration when I designed this case. So let me see if that's enough. just barely push a little bit without stripping the wires. It's just barely making it. It's, oh, actually it's this one that it's not making it. Hold on. Okay, hold on. These leads bent while I was pushing, so that's why they are not fitting through. Let me see. I might need to make this a little bit bigger too. So yeah, let's do that. Very carefully not to cut the wires. I mean, would just require to solder them again, but we don't want to do the same work twice. Yeah, I think that should be enough, hopefully. Okay, let's see. Try again. So as I mentioned, the worst part of this project is not so much the complication of it, because it's not complicated, is the tightness of the spaces and being able to fit everything and fit everything in its place. But let's see if I manage to do it now. No, I'm gonna have to do this bigger. Okay, let me just try these holes bigger. I might redesign this to make the holes bigger. They don't need to be this tight, so when I share this piece online, they will have bigger holes to account for shrinking tube. I think I might have cut a little bit the red wire, but it's only the insulation. Okay. Let's see. Hi Mix, we're building this. What do you think about it? I know you're not an Apache lover, but you can actually fly the Hind with this as well. I'm fighting with this, how you call this support. I need to fit some wires through, and because of the tight space, I designed it with a very tight space, and the heat shrink tube is not wanting to come in. Let's see. See this pin bent, and it's not wanting to go in. Come on. We're almost there. Yeah, I think we're there. Yeah, finally. I think that's good enough. Yeah, that's good enough. All the wires fed through. Finally. Thank God. Okay. So, now what do we have? Let's revisit this. We have these two leads, which are for the push button here. We can just move them aside. And then we have all this bunch of wires. It looks crazy, but it's not that much. We have the ones that we originally cut for the ground positive, negative, positive, and two analogs, which are orange and yellow. So orange and yellow are coming from out of one of its holes, and we daisy chained these wires, these red and brown wires. So we have a short brown and a short red wire coming out of his, and then since these were too short to fit through here, we added a yellow and a green for the positive and negative of this the potentiometer of this side. So what we are gonna do now is just cut this wire to the same length approximately. So the yellow and green. And now we have yellow, green, which are positive and negative for this potentiometer, and then this brown and red, which are positive and negative for this potentiometer. And as I said, it doesn't really matter which one you plug together. So we are gonna do brown with green, for instance, but we could do brown with yellow. It doesn't really matter. We will be fixing whatever issue we have with polarity with software. So we strip them out. As I said, I'm doing brown and yellow together. We'll just twist it together like this, brown and yellow. And remember, this brown is also coming out, and it's coming out of this one. This is the one that is going to be providing the ground. So all these are together. Let me grab the helping hands again. Okay. Now they split. Thank you, helping hands. You're not very helpful. Okay, so let's twist them again together. Solder together. Okay. And a little bit of shrinking tube, not to leave any of these wires exposed. So just like that. Whoop. Come on, there. Okay. And then I'm gonna do red and yellow. Just like that. Twist them together. And solder them together. Mix. I think I called you mix. I don't know why. Okay. Perfect. So we are done with this. You can see there's 4 wires coming. Let me just take the magnifying glass out of it. We have 2 wires for the push button and 4 wires. There's 4 wires here for the analog, the 2 potentiometers. Okay. So basically, every potentiometer has 1 lead coming to ground, 1 lead to 5 volts, and the 2 analog ones. And now we can attach this to the head of the flight grip, sorry, the mission grip. And for that, I have some I think 2.5 screws. I have an assorted, and yeah. So I think I'm gonna use this one, which is 2.3. Yeah, this is a 2.3. M2.3 by 8, but you can use whatever. I mean, you're gonna be able to fit uh, different types of screws in here, lengths and all that. Just eyeball it. It's not a big issue. So just I'm gonna fit the first one. Again, this one in particular is at 2.3, but I think at 2 would also work. It's just that I don't have long ones. This is the longest one I have. 2.3 by 8. So let me fit it in a little bit with the first hole. There. And before tightening it, I'm gonna do the diagonal so everything gets squared. Is it in? No, this one is not in. There. Okay, I think both of them are in. Let me just go back a little bit and then in. Let me just grab a bigger screwdriver. Otherwise, I'm gonna strip the screw. There. And make sure the joystick moves freely. And this is not going anywhere. But just for the looks, I'm gonna add the 4 screws. These are also black screws, which is nice because they are they look good against the black of the 3D print part. And this is going to be the end of this video. Yeah, as you can see, we have this button, this one, you can push, perfect. Okay, this is gonna be hidden inside here, so it doesn't really matter that it's like that. You won't see this. Next video, we will be creating the 4-way switches, these 3 ones at least, and there's gonna be a lot of wires coming out of here, so we will also be gluing this together like this with all the rest of the wires in here, so they are out of the way, because otherwise they could interact against they could be in the way with the trigger, and we don't want that. So we're gonna feed that from behind the trigger here. There's a slot, and to keep them in place, we'll just glue this with hot glue like this. And at that point, so next video, we will be able to actually close this grip, and we will have the mission grip finished. So yeah, I think we're gonna leave it here for now. Just one thing, just to make it beautiful, I have already printed the cap for the joystick, so I'm just gonna show you how it looks. It's really nice, and it just adds a nice touch to it. There you have. It looks like a little bit of a cup. There you are. So thank you very much for joining. I hope you enjoyed it. I hope you will be able to actually start yours as well. It's a really nice thing to have. And if you like helicopters, believe me, it's night and day. Flying them with an actual collective. It doesn't need to be an Apache. You can use this collective with any other helicopter, and the immersion and the experience of flying a helicopter with a collective instead of a throttle, something like this. It's totally different. I mean, it's a whole new experience, and I love it. It makes it so much more realistic. So I do really, whether you build mine, you build another one, or you buy one off the shelf, I do recommend, highly recommend, you get a collective if you like flying helicopters. So yeah, that's going to be all for today. Thank you very much for joining. Thank you very much if you are seeing this afterwards in YouTube or in the VOD. Feel free to contact me for any questions that you have. And as I said, we will be soon doing the next episode. So I hope to have this finished by the end of